Hello and welcome to a very sunny Vilnius, the capital of Lithuania, where Life Sciences Baltics is taking place. I'm Jim Cornell from Deep Tech Digest, and we're here to check out just some of the companies that are exhibiting and taking part in the event. So if you could just tell me a little bit about the company.
Okay, so my name is Linas Jonušauskas. I am PhD in laser material processing, and this is the company Vital 3D Technologies. So if I would need to describe this company very briefly, it's basically technology that blends biotechnology, photonics, and engineering in order to create a viable, printable organs for transplantation. Basically, this is a prototype of the system that is using laser as a key tool to cross-link material and therefore create 3D printed structures. And because we are using very specialized femtosecond lasers, of which Lithuania is very famous of, we can actually print with living cells inside the material. And our goal eventually is to, as mentioned before, printing transplantation-ready organs. Of course, this is a bit more down the line, so there are other things that we are doing right now. So the printer behind me is a general purpose printer that can just print with very high resolution, which is around 1 micrometer, structures that are centimeters in overall size. And we are planning to exploit that in order to produce stents, microfluidic devices, scaffolds for cell growth, etc. So we see this journey as a long endeavor, but we are hopeful that we will provide for market and for general society products and services that would be beneficial even now, all the way to the point where we are comfortable and approved of organ printing.
And is that in Lithuania or beyond Lithuania as well?
Of course, this is an international endeavor. The company itself is based in Lithuania, and again in Lithuania we have very good basis for such a startups because we have laser people, biology people, engineers, etc. But of course we realize that what we are creating will impact the whole world. So this is why our business model is not limited to Lithuania, and of course our partner portfolio is not limited to Lithuania as well. And we are now talking with various companies, institutes and universities that will hopefully help us co-develop this technology toward it being reliable, repeatable, and most importantly adhering to the regulations of European Union, US and other countries.
Right, and in terms of your timeline, obviously you can't be exact, but what's the kind of timing on being able to roll all of this out?
So the printer is ready as it is now. So we can at the moment print stents, we can print microfluidics and scaffolds. Actually some of the examples are here as well. And the kidney as a whole, well, it's a long process and it's very hard to guess at the moment what will be the exact timeline, but we hope that within 1 decade we will have very positive result in this direction.
That's very good, and you'll need help from partners?
Of course, and this is why we're here in Life Science Baltic. This event so far astonished us by the amount of people who are willing and interested in collaborations. So we are very open to, again, work with institutions within Lithuania, Europe, US, or anyone who is interested in co-developing technologies, co-developing solutions, and overall just making world a better place with better medical solutions custom tailored for each patient. Whether it would be stent or whether it would be kidney and anything in between. This is our scope and this is our vision.
And I assume that the technology is always improving as well?
Yes, yes, and we are working very hard to make sure that we are always ahead of the curve and bringing new capabilities and solutions to the market and commercializing them as fast as possible. Because we realize that if we have something good, we have to share it immediately. So of course we printed multiple structures. So basically this is a stent made out of hydrogel, and these can be made to be different sizes, different architectures, and literally custom tailored for each individual patient. And we are not actually competing with current stent technologies because they're made out of metal and a lot bigger. We're actually supplementing them in a sense that these can be made out of biomaterials, these can be smaller, and these can be potentially implanted in some areas where metal ones are either too invasive or just too big. Also, this is a scaffold for cell growth. So something like that could be used for, let's say, bone regeneration or something like that, because this particular one is hard. But another area we're working on is, of course, material sciences. And our goal is to use, let's say, soft and or bio-derived materials such as hydrogels, collagen, or something like that for soft body mimicking scaffolds that would guarantee the fastest healing and highest biocompatibility. So in essence, this is, although it's based on very advanced femtosecond laser technology, for which Lithuania is very famous of, essentially this is a stereolithographic printer. We have a material bath here, we have a material platform here, which is now moving down for demonstration purposes, and the laser beam comes from the top, and the platform moves in the material vat, and this is how we layer by layer print required structure.